So my name is Farhan Shaikh. I am working as a senior energy analyst in a Delhi-based startup named Smart Joules, and I've been working here from last 2 years, and I've been working in this energy sector from last 4 years. So thank you, IEA, for giving me this opportunity to present. So I'll start with the presentation. So talking about the company, so my company name is Smart Joules, as I've already told. So the mission, the company has been started in around 2015 with a mission to eliminate energy waste, and with a vision to eliminate around 29 million tons of carbon by the end of 2030. So the objective is to make energy, if energy savings simple, substantial, economical, and visible. So I'll be talking about the encouraging energy efficiency through innovative business model. So what kind of business models our company follows, which is encouraging other people to join hands with us in saving energy. So to start with, so we are around a team of 140 people now. We started with 10 people spread across all over India and also in US. So I'll not take much time over here going forward. So our major clients are hospitals, commercial buildings, pharma industries, and some industries where compressed air is being utilized. Going forward, so when we see the major issues in why the energy efficiency is not there, or why the energy is being wasted, we have identified there are three major problems. One is the poor design of the equipments which are being which are the energy consuming equipment at the building, which are not properly designed, not so these equipments are being designed with the help of consultant and contractors, so which these people don't have stakes in how these equipments are going to perform over the lifespan. So they focus on the initial cost of these equipment and not the lifespan of how, over the lifespan, how these equipments are going to perform. The another thing is again this because of this the wrong equipments are being selected, and again this prioritization is not there on the life cycle cost, and again the first initial cost is being considered. And the last part is about the automation and the lack of skills, and with the operations of the equipment without any data or without any insights. These are the major things which are resulting in the lot of energy being wasted. So this is where we comes into picture. So this is our business model, Joule Pays, wherein we call it pay as you save. So herein, what we do is we go to a facility. So the major issues or the major setbacks of any facilities to take up the energy efficiency is like is because of the huge investments are installed, huge investments are involved, lack of expertise, and a lack of knowledge in energy efficiency. So this is why these people are not getting involved in the energy efficiency. So what we do is we go at the facilities, we take care of all the investments, we take care of all the replacements of the equipments wherein which are not so much efficient and all, and we also take care of their operations and maintenance and everything. They don't have to invest anything, they don't have to do anything about the equipment. Only thing is we will commit them that we will save energy, and on that saving only we will earn. So that is how this business model works. So I'll just explain it with a simple example, very simple example. So it's like the existing energy bills of a building is suppose $100, for example. So what we will do is we will our commitment will be we'll be reducing it by 20%. That is, from $100 we'll be bringing it down to $80. So the savings is coming around $20, right? So Smart Joules share will be 70% of this $20, and client share will be around 30% of this $20. So here the client doesn't have to invest anything in energy savings. We will invest in all the retrofits and all the equipment replacement. We will design the proper equipments, and we will also operate these equipments through our expertise and through our operations team through the overall contract period of 5 years. And after that contract period is over, all the equipments and everything is under client. The client can take care of all those things. So it's like a win-win situation for both the sides, and they don't have to pay anything. They don't have to worry about the operations and maintenance of their plants and or their equipments. And ultimately the bottom line is both of us end up saving a lot of energy. So this is one of the business model wherein the overall building energy is being reduced. The baselines are being prepared based on the existing bills or last 3 and 4 years bills, and on top of that, whatever energy savings we are bringing out, both of them are earning from that. So this is like a committed saving of 20%. If we save more, we earn more, they also earn more. So minimum of 20% commitment is there, and on top of that, whatever savings we achieve, it is like a benefit for both the sides. Similarly, one more model is there as Joule Cool as a service. So herein, it is quite similar to Joule Pay, but again here it's mostly related to the HVAC part. So as you have already shown initially that the cooling service or HVAC consumes the maximum amount of energy in a building. So here we mostly focus on the HVAC equipments, how these equipments are performing. We conduct audit, and then we replace or retrofit the inefficient equipment. Then we operate those equipment and maintain those equipment through our building management system, through our expertise, and we claim a fixed amount only if we achieve the committed energy savings, and not energy savings, energy efficiency. So this business model is basically related to energy efficiency. So for example, now if I give the energy efficiency of a chiller plant, for example, is around zero point 0.9 kWh per TRH. So it's like the efficiency of a chiller plant. They are spending around zero point 0.9 kilowatt of energy for getting 1 ton of cooling, right? So this is what is the existing conditions. So our commitment will be, we will be reducing it by 20%. That is, instead of zero point 0.9, we will be coming in, we will be replacing your equipment, we will be operating your equipment, we will be optimizing your equipment, and we will be bringing down your energy consumption for per ton from zero point 0.9 to 0.72. And it's like energy efficiency improves by around 0.18 kWh per TRH. And this is how, if we achieve that committed, say, if we improvement in efficiency, then only we will get paid, otherwise will not be getting paid. So it's like our stakes are involved in throughout the lifespan of this contract, and we have, if we have to succeed, we will have to save energy by hook or crook. And again here, win-win situation for both the parties. So this is how we do it. So we design efficient when we comes into picture. So we are bringing in our efficient design, selecting right equipment, and operating the equipment based on the data. So based on the data, the optimizations and operations is happening. So maybe we can talk about a little bit in detail, or maybe a very simple example I've taken here of a ceiling fan. Everybody's having a ceiling fan at their home. So this is an example of a correct design and correct equipment, considering the life cycle cost of the equipment. So when we so this ceiling fan cost us around 1200 to 1300 Indian rupees, the initial cost when we buy a regular ceiling fan. So and it is consuming around 70 watt, and it is running around 18 hours daily. So on an average and annually, it is consuming around more than 3000 rupees in a year. Similarly, there is if we go ahead with BLDC fan, that is brushless DC motor fan, it is going to cost almost double what we are going to have with the regular fan. So it is around 2500 or something. But if we look at the overall expenditure or energy spent on this fan throughout the year, is almost half of what we are consume normal fan is consuming. It's around 1500 rupees only. So from 70 watt, this fan is consuming only 32 watt with same amount of flow, with same amount of comfort, but the energy consumption has come down by almost 50%. So this is how the annual saving that is coming out from one simple fan. So this is just a simple example. This we scale up for all the equipments available at site, and this is how the energy is being saved simply. So, and this is how it is made simple, substantial, visible, and economical. So how we do it is like this is our building management system, IoT building management system, DJUL. So it's like what we say is you cannot improve until and unless you measure, you monitor. So this Joules system continuously monitor and optimizes these operations of these equipment, and based on the data, it automatically optimizes the equipment operation, and that is how the efficiency improvement is happening, and that is how the energy efficiency, energy saving is also being happening. So maybe we'll discuss in detail about the case. This is one of the dashboard, or the monitoring of one of the sites, one of the hospital sites, wherein how much energy is being consumed in the last 24 hours, how much is being consumed in the last 1 week, what is the savings till now, what is the current load. Everything is being monitored continuously, and if any abnormality is seen, then the action is taken accordingly. This is one of the chiller plant data points, wherein the chiller operation, current operating conditions, and at what data point, what is the parameters, and what are the condition at which these chillers are operating. Those things are captured, and also it is being controlled, wherein we can discuss about that in the next slide. So this is one of the case studies wherein the overall impact of the smart joules have been highlighted. So in last 1 year, so uh, it's like 1.4 lakh kWh has been saved at this site in last 1 year only, which is costing around 14 lakh INR, Indian rupees, have been saved, and which is the CO2 reduction is 150 plus tons have been, the CO2 have been reduced from the atmosphere. So one more API we follow, we usually follow, is the number of household, Indian household, that can be light up with this much energy being saved. So it is more than 1600 plus Indian households. So how we do it is like, this is the simple case study with a very simple example of a set point optimization. So in our AC in at home, when we run a AC at our home, if we operate it at a lower set point of around maybe 23 degrees Celsius, it is going to consume more energy comparatively if we operate it at 25 or 26 degrees Celsius. So same, but that is all we have to do manually, and whenever it is required based on our requirement, that is how we operate it manually. But in chiller plant, doing the in a big commercial building, changing the set points and everything manually becomes very difficult. So operator usually run it at the same set point throughout the day, either in the daytime, in the night time, when the ambient condition is very severe or very high temperature, or when even though when it is lower, the temperature is lower and the cooling requirement is not there, they run it continuously at the same constant set point. Maybe one or two times they will be changing. So this is the example of before optimization, or before the DJoule is being implemented. After the DJoule is being implemented, the set point is being automatically changed, as you can see in the second graph. This is the actual real-time data of this building management system. So based on the ambient conditions, based on the cooling load, based on the occupancies, the set points are automatically being changed. If the cooling requirement is more, automatically the set point will come down. If it is higher, then the automatically set point will go up. So approximately it is savings around 90 kWh per day from the chiller plant only, from this only the set point optimization. So likewise, we optimize pump operation, cooling towers operations, all those things dynamically and automatically. This modulation happens based on the requirement. So this is one more case study of the same site, wherein this is how the monitoring of the plant is happening, wherein the overall HVAC equipments are visible on a single page, and all the controls and everything can be done from here. This is the another example of one component wherein all the parameters are being monitored and controlled. And this is Joule recipe. We call it Joule recipe. This is nothing but a optimization logic and algorithm which we deploy at site to operate each and everything dynamically based on the atmospheric conditions, load, and occupancy. So same example of set point, this dynamic chiller set point modulation. Similarly, we dynamically modulate the pump frequencies or pump speed as per the flow requirement from the building. So here also it is not constant, the requirement is not constant throughout the day. So based on the variable load and variable requirement, the modulation is happening. Similarly, this is the operation of the cooling tower, wherein the cooling tower has to operate sync with the ambient conditions. If the ambient is higher, it has to operate at higher frequency. If it is lower, then it has to operate at the lower frequency. So the graph shows how this is in sync with the ambient conditions. So I'll not go much into detail about the technicals about the cooling tower, but just an example of how the optimization logic optimizes the operations of the equipment. So again, here this is the actual real-time example of this site, wherein it was operating at 0.92 kWh per TRH previously, uh, before uh, before the SJPL, before Smart Joules intervention, which has come down to around 0.71 kWh per TRH. For the same tonnage requirement, for the same TR delivery, we are consuming from 0.92, we are consuming only 0.71 kW for 1 TR of cooling requirement, which is almost around 22% improvement in the plant efficiency. So so this is like this is one of the this is our portfolio, wherein we have the sites at different locations in India, almost more than 13 states, and on an average, on each site, on an average, we are bringing down the energy consumption by almost 23%. And because of this innovative business model, these people are happy to join hands and contribute in the energy savings. So this is again the overall impact of the overall sites what we have across India. So it's like 1.26 million household electric have been electrified. 132 million kWh have been saved till now, which is almost 103 crores of Indian rupees are being saved. And again, 85,000 tons of CO2 have been eliminated till now from the start of the organization, and we are still counting on it. This is one of the recognition or award that has been received by one of the hospitals that is being under Smart Joules purview. So so the from the Indian National Energy Benchmark, this hospital has received the award. So the EPI, that is the Energy Performance Index of the of these hospitals, have come down from 124 to around 108 in 2018-19 as compared to 2017 and 18. And this is some global recognitions that Smart Joules have received in terms of energy savings. So I think that is it from my side.